Welcome to today's session with Mr. Ganesh Harinath. A little about our speaker for the day. Ganesh sir is currently the Vice President and CTO at Verizon Media. Today, sir will be talking about how 5G intelligent applications would help enhance human experience in the future by citing a few examples and how we all can play an important part in the ecosystem. So, welcome, sir. How are you today, sir?
Oh, Amog, doing very well as always. I mean, I get very excited to talk to folks back home, and thanks for really having me on the platform today.
All right, sir. So, I would now request you to please take over the platform and start with your presentation, sir.
Oh, wonderful. Thanks, Amog. So, hi, everyone. Good morning. I'm sure you're having an exciting day, Saturday morning in India, a lot of sunshine there. Interestingly, I had my visit very recently. I was there to see my mom and back here in the US, and a fantastic opportunity for me to really start to share my view in terms of what we do at Verizon Media, primarily focused on AI, and most importantly, my focus in the last year and a half has been on edge intelligence. I'll start to slice through, giving some historical evidence how the world evolved through due to internet transformation, and slowly start to bring you into how we have been applying machine learning in our own ways. And most importantly, the bulk of the talk would be very forward-looking, with citations around some of the examples which I envision that would actually happen in the foreseeable future. So with that, my name is Ganesh Harinath, and I was born and brought up in Hyderabad, and I'm a student out of Osmania University, where my background is electronics. It's been a fantastic journey. I call it full circle because from electronics, I went to software, and now I'm really starting to understand a lot more about electronics, because it's convergence of electronics, AI, virtual reality, and so on is what I've been doing in the last few years. So with that, so when we take a closer look at how we came where we are, we all, especially when it comes to me, 20 years ago, internet was just evolving, and it really changed the world. But for many of us, we just attribute that to either internet or a smartphone. But there was a convergence of technology evolution that really happened, which really changed our life. I mean, today, I can't go out without a phone. When I have a phone that is connected to the internet and I have access to all the application on which I depend on, life becomes easy. I feel very secure wherever I go. I can get things done very efficiently, and then so on. The slide that you're looking at right now, Yahoo.com, say for example, I typed from Hyderabad 20 years ago, and there was no CDN. There was internet, but there was no content delivery network. It would have taken a minute or two before the page came up. Eventually, the undercurrent, which is called content delivery network, Verizon, we have about 150 plus CDNs. They're mini data centers. What they do is they actually cache content and start to distribute the content depending upon from where the request comes in. Happens magically behind the scene, and not many people even notice what's the undercurrent to power applications, internet content, and then so on. But I cite this story because just evolution of one technology will not disrupt. There should be evolution of multiple technologies which would converge to really enhance human experience. And then today, the world is really changing in a very, very accelerated way, primarily. And my view and vision as we move forward, everything that you touch, feel, see would be powered by machine learning. And it's no exaggeration. I can take my own example. Today, I go start to watch television. Hardly I would have to press any button because YouTube knows me very well. It recommends content after content to my taste, and then it just goes on, and I can just spend hours. Sometimes it actually does much better than what I can do flipping those switches. But when you take a closer look at 10 years from now or 20 years from now, some of the examples that you actually see on this slide are really are going to be real. And today it's conversational. And let's take, for example, robotic arm surgery. There's a lot of concept evaluation that is actually happening. It may take 10 plus years. But at a very high level, robotic arm surgery is nothing but a doctor, a specialist, say from Hyderabad or Vellore, is performing a surgery on a patient in Los Angeles. And so today, just to imagine that, it's really fascinating. And I'm saying 10 plus years from now, that's going to be real. But what is the undercurrent for a compelling capability like what we are discussing right now? Robotics is important. Artificial intelligence is super important. Virtual reality is important. And more than all these things, you really need a fabric. Evolution of 5G and combination with fiber would really disrupt the ecosystem by converging these different technologies to make to enable solutions like what we are discussing, that is robotic arm surgery. And another classic example, and I'm really fascinated with this example, and I see a timetable to be 5 years from now. Today, if I order a transportation, a car, to move from point A to point B, and in my case, I live in San Ramon, a city close to San Francisco and Sunnyvale, and I have to go to work. Today, it's just a car that takes me from here to my work. And I spend an hour and a half. In the future, what I envision is when I really order a transportation, I get into a car, go to the closest drone point, get into drone, get dropped off in a different location, get into car, and get into work. No doubt, on the surface, it might appear that there are so many hops, but interestingly, I would be reaching my destination in 15 minutes or 20 minutes when compared to today, an hour and a half or so. And again, when you take a closer look at the technology, the drone technology in itself, the capability of autonomous drones is going to be real, where it's going to really detect what's around. It can plan the route. It can take you safely from point A to point B using 5G network, complying FAA regulations, and so on. There's a lot of work that's actually going on in this space too. But these are very forward-looking, and for us, especially from academics' perspective, very recently I started to interact. I started to have interactions with Berkeley, a little bit with Stanford, and so on, trying to take a closer look at what's happening. A lot of technology, with specific emphasis on machine learning, is really disrupting the ecosystem. No doubt, I have spoken a lot about these very forward-looking solutions, but even before we actually get there are a lot of other things that we would like to solve before we get there. And there's a lot of emphasis and work that's actually going on in bits and pieces, which we are trying to stitch together to make solutions like what I'm about to say happen. And factory automation is a classic use case, which is on the right. And on the left is autonomous car. Many of us, we are starting to have autonomous cars, which has a 360 view. So it has cameras and sensors which can actually view cars only in front of us, not 3 cars in front of us. But that's not going to solve the purpose of route planning of the car and safely get to that destination. So the car is expected to talk to the car in front. It's expected to talk through 5G to a smart, intelligent service to get more information for route planning and safely take a person from point A to point B. And I envision in many cases without a real driver, and that's in 2 to 3 years. And this is no exaggeration, at least from my observation, where things are headed, at least in the United States. And I'm sure we'll start to experience all these capabilities wherever we are in the globe. Now, let me spend some time on the example on the right. Now, when you take a closer look at the new or next generation factories, you'll see a lot of robots walking around, moving shipments, packaging, assembling things, and there's going to be a lot of information that needs to be processed. And for an environment like this, a complex environment like this, to really perform very well, it's super important that we have machine learning capability that can ingest all the signals from robots, sensors, cameras, and start to surface insights. And also, in many cases, take corrective actions too. That way, you have the next generation factories where majority of the actions are taken by computers, robots, and so on. Robot, again, is powered by computers. But primarily, the undercurrent would be machine learning, and it's no exaggeration. But in an example that I have cited on the right, where it is expected that the compute that is really required to perform these machine learning capabilities is going to be very, very close to the factory. So what does it mean? Now, today, if I were to order infrastructure for applications, the class of applications that I'm looking at, I would need cloud, and I would also need servers in different locations, because the industries would be in many different locations. Why do we need this? Now, I'm sure many of us are very closely associated with the concepts of machine learning. And the foundational aspect of machine learning is this a concept called model training, where you take an algorithm, it is an algorithm, and you induce smartness into the algorithm by feeding more and more data, and it becomes smarter and smarter. And this activity is called model training. To really train models, and especially computer vision based model training, you really need tremendous amount of compute. And in this case, it would be a combination of CPUs and GPUs, racks and racks, depending upon the data that you would actually feed. And this needs to happen on the cloud, irrespective of what kind of solution, what class of solutions you actually build. But once you have the trained model, which becomes the brain of the application, that needs to be deployed onto the edge. And the edge in this case is the factory environment. And that's where, when you take a closer look at it, the entire infrastructure paradigm is going to change, and the way how we approach building applications is going to change. And the release is not going to be release 7.1 dated May 17th, but highly likely the release frequency would be very, very high, because you have to retrain these models on the cloud and very seamlessly push it onto the edge. And my team is very deeply entrenched into making this aspect very, very simple as much as possible under the program Leo, which we socialize outside. Not the specific IP, but conceptually, what does it take to really have distributed infrastructure, but being able to build and deploy machine learning applications? So I'll actually talk through some of these capabilities down below. But the concept of edge intelligence is really picking up. And the difference between edge intelligence and regular traditional machine learning applications, the traditional machine learning applications are all built and deployed on the cloud. And the edge intelligence application, primarily driven by SLAs, and SLAs are nothing but the inferencing should happen in less than 10 milliseconds. That's very, very very tight SLAs, and you can't expect to have your machine learning models run on the cloud, feed all your video data to the cloud, and apply inferencing frame by frame, right? Every second you have 30 frames in many scenarios, and you're going to see a lot of lag. How do you avoid that? There are certain aspects of the machine learning model deployment that you would really have to bring it closer and closer to the edge. So when you take a closer look at what you're seeing right now, traditionally, the way how we all approached building machine learning applications is as follows. You use the cloud infrastructure to train the models, and then you deploy your trained models on the cloud. You build the business logic, you build the UI, and then make the application operational and make it work. It's fantastic. But oftentimes, these are very batch-oriented applications. And my team at we've been doing this for over 8 years at Verizon Media, just as a group. And interestingly, it worked up until a year or 2 years ago. But I call the next generation application. It's a very different class of application. The term machine learning would continue to be used, but the way how we would start to apply machine learning would be very, very different. And in this case, I'm just highlighting the inferencing part, but it's beyond inferencing, which I'll touch upon as we go down a bit more in detail in terms of what kind of capabilities you would need on the edge versus cloud, and start to move those capabilities to, I call the 2U box, or an appliance in a factory environment, or ideally a CDN, which is nothing but today it's a content delivery network. Like I mentioned before, even Verizon Media, we have over 150 CDN edge locations across the globe. And this edge deployments would actually start to scale, but they're going to become even more intelligent, where you can actually start to deploy machine learning based applications. I'm hoping all this is making sense. It's very heavily loaded, by the way. You have to slowly start to slice it and then start to understand. And I'm making an assumption that many of you on the call are already deeply entrenched into building machine learning models and then trying to make use of these models in solving some of the problems as part of your courseware. But in an industrial environment, building applications, especially when you take a closer look at next generation applications, it's going to be a very, very different paradigm, where you have to pay utmost attention to how you train the models versus how you deploy the models. I'm hoping it's making sense. Now, this is just an example, a classic example. We are actually building applications in the space in a factory environment, where not one but many video cameras are very closely monitoring how the servers are assembled, they're packaged, and then they get shipped. In many stages, you have not one but multiple video cameras. And interestingly, these video feeds should be fed into platform. I call it Leo, but it could be any machine learning platform which has inferencing capability, meaning every frame comes in, you apply different kinds of computer vision models, start to surface insights. A classic example is a PCB is being built, and somebody is actually putting in a CPU. And they did not put the CPU properly, and it did not sit well within the PCB ecosystem. The camera will be able to actually detect it, and then it will be flagged. So it gets stopped well before it actually goes down the line, where they assemble the whole thing and it doesn't work, and then they have to go back and then figure it out, which is astronomically expensive in today's world. And this is where machine learning would really help us auto-detect faults to help take corrective actions near real time. This is an example that I try to cite. There is a vision aspect, how you approach building solutions, like what I'll be sharing in a few minutes. And there's a need, being part of Verizon Media. What I'm saying comes very natural to many of us who strategize and build drone inspection applications. To me, I can visualize it in a very, very simple form. And I'll cite how all these things can be stitched together. And also the reason why we, Verizon, would need something like drone inspection. Just to give you an idea, just like Reliance in India, Verizon is a very large telco. One aspect of Verizon, or one product or service from Verizon, is the wireless capability. We have undersea transatlantic cables. We run transatlantic cable. One of the largest internet backbone is powered by Verizon. We have a drone company. We have a robotics company, and the list goes on. So in our case, Verizon has tens of thousands of infrastructure, in this case, cell towers, to really keep tabs on these cell towers and then try to understand if there are issues. It's very, very expensive to send people to go climb and look for faults. The best way to do that in today's world is to really fly a drone close to the tower, try and understand what the issues are, and then be able to take a corrective action. And then I'll start from the vision. The vision that I have for Verizon is our network performance engineers or revenue assurance engineers, if they really identify or detect an issue in a specific geographical area, they have a lot of signals coming from the network where they can really make very intelligent decisions in terms of, oh, this is the issue, we have to make a corrective action here. But in few cases, they might not be able to from those signals. So they literally have to send someone to inspect these cell towers physically. And I'm saying we're going to change it. So these performance engineers would just press a button, and then the drones automatically would take off 2 or 3 in a geographical location and then start to scan the tower infrastructure, which is equipped with video camera, RF sensors, and a couple of other sensors, and then start to stream this information live through our 5G network to the LEO platform, where we have the smarts, here in this case, the trained machine learning models deploy, which would start to perform inferencing and surface insights in terms of what the issues are. That way we can take corrective actions appropriately in a very cost-effective, in a very timely manner, and in a very using very advanced capabilities. And being part of Verizon, it is very natural for us to think solutions of the type and scale that I have explained, primarily because, as I mentioned, Verizon acquired a drone company a few years ago. What it does is, to really fly a drone, you really need an FAA approval. And you give a flight path, and then it gets an approval within minutes. Now you have an approval. Now, as we look forward, autonomous drones are going to be very normal and natural. And then you give an instruction to the nearest drone to just fly to a specific geographical location based on the flight path, and then do the scan and ship all the video camera and sensor data to the LEO platform or an equivalent, and start to surface insights. So this is a classic example where the world is headed. This is very forward-looking. As of today, we really fly drones manually, get the video information, and then just process this information to surface insights. That's happening on the ground as we speak. Now, how do we start to simplify the complex story that I explained? I was talking about distributed infrastructure. We were discussing model training on one end, inferencing on the other end, and then it's going to be astronomically complex. And how do we simplify? Our team embarked on a journey to really bring in capabilities, primarily from the software technology stack perspective. That way, we start to build a software layer where we can very naturally start to separate inferencing and separate training, and then distribute these workloads in different infrastructure, but seamlessly connect to the cloud. Now, I call this, just to keep the conversation very simple, I call the pink boxes, which are near real-time runtime capabilities, the blue boxes, which are batch-oriented, which would be deployed on the cloud, ideally, which are required as basic components to build any machine learning application. To just very quickly take you through the flow, let me do a time check. Just want to be, to quickly take you through the flow. Now, These ping boxes have intelligence. It can take actions. You can actually close the loop by sending signals to take a corrective action. You can extract the feature and then ship it back to the cloud on the near real-time data. And most importantly, this is like super important for all of us to keep in mind. The traditional approach of doing a release of an application once in 3 months or once in 2 months is just going to go away. Maybe you might not do a UI release, but it's inevitable that you actually do a very frequent, near real-time machine learning model release. And this is nothing but you actually train it on the cloud and seamlessly push the trained models onto the edge, which gets consumed within the application ecosystem. If time permits, I'll just go do a quick demo as well. Let's see how we do on time. And again, I don't want you to be overwhelmed too. So this journey is just beginning. It's very easy for me to speak these things very fluently because we have been doing this for quite some time. There are only few messages that I want you all to take back with you. And that is, okay, the world is changing. Everywhere machine learning would be applied as much as possible. But it would be a very distributed ecosystem. Okay, how can we start to think about making our machine learning applications work in this distributed environment? And that's an art that I really want you all to start learning very early on in your career. That way, you really be in the forefront of building machine learning applications and not fall behind, because it's going to be a drastic change very, very soon. Right? So now, just highlighting very quickly on some of these boxes, you really have to ingest data. Could be camera data, it could be other sensor data. It can just come in. It can go through an event processing engine, which can actually filter the data, transform the data as needed. And the first thing that would actually happen is apply a machine learning model and start to surface insights that can be used within an application ecosystem. In few cases, to take a corrective action. In few cases, it will just show some graphs and pictures in an UI where people would pay attention. And we have scenarios where we actually send out alerts notifying there are serious issues, a corrective action has to be taken. But if you watch the arrows carefully, there's a lot, and these boxes are like very, very basic. There would be like tens of boxes that we would have to actually start to add depending upon the applications that we would continue to build. But this is just to give you a taste. And a lot of emphasis is only on data processing, but there's a lot of business logic boxes that you might want to add and build. There's UI, the security boxes you might want to add, build to protect the ecosystem, and so on. But what I'm saying is slight digression, but I want each one of you to start paying attention to the compute resources that are needed to run machine learning models. It might appear to be trivial right now. It's a non-trivial problem, especially when you start to push the machine learning models closer and closer to where you really need to perform inferencing. Yeah, this is just taking back to the same slide where you would have to let me flip between the slides. You would have to move these ping boxes onto CDN edge, and or in different scenarios, you might want to put it on one server or two servers in a factory environment. And a lot of it would be driven based on the SLAs that you have for the application inferencing. But one thing that I want you all to keep in mind when you really architect systems, as you make it more and more distributed, it really has to be meaningful, because it's going to be astronomically expensive to have infrastructure distributed all over the place. So please keep that in mind. Let me do a time check. So let me spend a few more minutes, and then we can start to have some conversation. What you're seeing is just a pictorial view of how the next generation applications will be deployed. The ping boxes, even before that, the red dots are nothing but you can actually start to imagine different cities where you have small data centers. The blue boxes are nothing but the factory environments where you really have 2 or 3 servers sitting there. trying to power your machine learning applications. And the green box is a centralized data center where the model training happens. But when you combine all these things together, it's such a heterogeneous infrastructure where a portion, which is in this case model training, that would actually happen on the cloud. But there are portions which are the pink boxes. If you go back and look at the slide, I'll be happy to share the slides too. That way you can take a closer look at it at a later time. But those pink boxes have to be shared on, have to be deployed onto these red locations and the blue locations for your applications to really work. And this is like a super busy slide. But this is reality. And this is where the world is headed. Look at the complexity. You talk about AWS wavelength, which is nothing but an edge strategy. Azure has an edge strategy, and same Google has an edge strategy, including Verizon. Verizon has an edge strategy too. And these are those pink boxes. Pink boxes would actually reside on wavelength or digital media services environment, and then so on. But like I said, for training, it really has to talk to the cloud. And again, on cloud, there are like tens of flavors of cloud today. Just a handful have been cited here, including Verizon's own cloud. You have Google, Azure, and the list goes on. And on the other hand, the class of machine learning models, unbelievable. It's really fascinating to actually see how the models are evolving, how the smarts can be applied within various applications to build. And the end goal is to build these applications. Drone delivery, video analytics, in few cases, crew safety, drone inspection, and the list goes on, factory automation, and the list goes on. But this is a loaded slide. But if we all start to pay attention to some of these boxes and then start to have a holistic view and try and understanding where the world is headed, then we will start to learn and do things right very early on. Doing things right here is nothing but having a mentality of separating out inferencing from model training. Eventually learn the art of keeping inferencing in a different infrastructure and model training in a different infrastructure, building connectivity between the inferencing infrastructure and model training infrastructure, and then so on. And that's an art. It would not happen just like that. We are all learning, including myself. It's very, very early on, but it's a required skill. It's a required skill to really design architect solutions and commercial solutions primarily, and in a meaningful way. Because in an isolated environment, all these things doesn't make any sense at all. But when you start to think about commercial applications, that's where we all want to go and then start to make a difference. And some of the solutions would be for social good too. And these would be distributed applications as well. And this is no exaggeration. So continue to invest time in starting to understand what edge compute is. Try to apply your learning about machine learning applications, and then start to separate the inferencing part from the model training, and then start to bridge the gap, and then do all these different things. Yeah. So with that, let me stop sharing the presentation. Let me see if I can figure it out. And
yes,
let's start to have some conversation. I would like to get some feedback from Amog, if you can share your view, because I want you to tie what you heard to what you're learning, because I want to learn from you as well, so that I try to.
We have a lot of very interesting questions in the chat box.
Sure.
Should we directly start with that, because I think we won't have enough time to cover them all. If it's okay with you, we'd like to start with those.
Sounds good. Please go ahead and move. I'll lean on you to read out those questions, and then
I'll read them out, and they'll be visible on the screen as well. Sure. So Reba is asking, so do you think edge intelligence will take over the ML domain? This is the first question.
Oh no, so it's an interesting question. So it won't take over, but edge intelligence would become foundation for building any machine learning applications in the future. So
Right.
edge intelligence, the way how you all have to start to visualize edge intelligence in today's world, including myself, if we have to do something, we just straight go to the cloud, right?
Right.
In tomorrow's world, where you start to see this next generation commercial applications, the application, this is where the concept of distributed application, this is very new, by the way. What I'm saying is very new. Not many people really understand the undercurrent too. I want you all to be in the forefront of starting to understand these things. The 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 application, I'll give you an example. A
Right, sir.
classic example would be the healthcare ecosystem. There are many hospitals, and the hospital data can't go out of the individual hospital because it's very private and protected. How do you apply machine learning independently, and how do you extract only the signals and then centralize it somewhere? That way it adds value for greater good for community, right? That's a classic example. So distributed applications are nothing but they are meaningful independently. Simultaneously, it has a greater meaning when you combine these insights together at a higher level.
Right.
So it's nothing will take over. They all would coexist, but the undercurrent is slowly the class of application would demand us as engineers to start to build applications slightly differently from before.
Right, sir. Right. We have one more very interesting question. It's by Sejal. She said she's asking, is full duplexing possible on a smartphone-sized chip?
Uh, it, so it's a very interesting question too. For sure, yes, silicon capabilities are really pushed in this direction, and
Okay.
the silicon makers are really paying a lot of attention. I'll cite an example. Today, this is a commercial example. You have a video camera, and you have, I don't know if you know the Teslas from NVIDIA, which is nothing but a GPU.
Right.
Almost you need one Tesla to process one video camera if you really apply streams and then apply machine learning for every frame, right? Look at
Right.
the amount of compute power that you need. So there's tremendous amount of pressure on silicon to actually directionally change and enable capabilities of duplexing, multi-processing, massive ingest, and most importantly, inferencing near real time too, at a very small scale too. At the end of the day, the best thing is for this to be a video camera as well as a high intense inferencing engine too.
Right, sir. Right. Okay, sir. Next question is, sir, has work been initiated on 6G, and how do you think it would make an impact on the existing network structure?
That's an interesting question. I don't have the specifics about the kind of changes that would envision between 5G and 6G. I'm still learning that space, but
Right.
definitely the conversations around 6G has already started. 5G is real right now in many of the countries. It's real. This To stabilize 5G, it might take a year or two, depending upon geographical location. 5G private, 5G private is nothing but in an industrial environment, having a 5G private network to connect all these different robots and things like that is very real right now as we speak, at least in the United States. 6G conversations, it's more conversational standards are being set. I clearly don't know the distinction between the capabilities between the two at this point in time.
Right. Sir. So I have another question on this only. This is my question. What can we expect out of 6G? Like, what will make it different from 5G?
Yeah. So this is I have to visualize to actually answer your questions, which I'm trying
Right.
to. 5G, when you take a closer look at it, the bandwidth is still 10x of what we have on 4G LTE or even more.
Right.
Uh,
Right.
the pressure on the bandwidth is going to increase at a consumer level. When I say at a consumer level, we are not talking about commercial contracts and so on. My phone has needs even more only because the class of applications would actually change from very two-dimensional to very three-dimensional. My phone might just be a chip on my wrist and I'll be typing in air. Just think about that. Imagine your phone projecting something in air. You're looking at it and then you're performing. It's gesture based. Look at the
Right.
amount of coordination that need to happen on the edge, and the amount of signals that need to send back to the central processing, right? So when you take a closer look at all these different class of applications, there's definitely bandwidth would be super important. Super secure, right? When the world is being decentralized, there is tremendous amount of security threat. The security posture is changing. So there will be tremendous amount of attention that would be paid around security and so on. And I don't know the timetable too. What I
Right.
envision is I can see drones already flying using 5G.
Right. Right. So, what applications do you think would be using 6G? Because I think right now, not even all phones are capable and compatible with 5G, right? So, what sort of applications would be using 6G?
Yeah, no, definitely. Now, to me, the way how I look at the more autonomous it is, the more back and forth it needs, because you can be autonomous, but it should have sensing around the ecosystem. Now, this is three-dimensional sensing because we are talking many feet above the ground, right? You'll see
Right.
a lot of flying objects, right? Just imagine the flying objects. And there's a
Mhm.
lot of coordination that would be needed. That's one space. And the second area where you really need 6G is to enhance human experience. All these are like very two-dimensional. You're still not getting close. You're still very far away from me. I can see you, but to
Right.
get you closer and make it real, like here, you really need more bandwidth. So this class, the application class that I have cited, really need
Right.
more bandwidths to make it more real.
All right. We'll pick up a few more participant questions before I start asking more questions. Um, all right. So, when do you think India could witness this change? Absolutely.
No,
I
I
think
think
she's
to
talking
me,
about that.
so I'll tell you my own personal experience. So it's so
Yes.
fascinating. It's so fascinating to see the developments that are happening in India, right? So when I looked at your college, that's like a five-star hotel for me. I've never been to a college like that, right? And look at all the sensor-driven gates, right? We are already there, and I don't see a huge difference between what we experience in India versus other advanced countries. And what I envision is a lot of fascinating things cost effectively will happen in India. People might do
Okay.
great things, right? So look at the difference, right? People might do great things, but it would be expensive. So while we do great things in India, we'll ensure that it is cost effective too, right? That's a
Right.
huge difference in what the statement that I'm making. And AI, I mean, I know there are fascinating companies, startups in India who are doing great things. We will continue to do that with commercialization of technology like 5G and things like that. It will really start to glue all these things together. The way how I see, we are not going to lag. Maybe we'll be in the forefront. And also, uh, this is where we all, as students, have to make best use of information available. Today, sitting in a remote village, assuming we have internet connectivity, we can't complain because through internet you can actually have access to material that is being used within Stanford, right?
Right.
So it's just the mentors like you who can actually start to socialize and then spread the culture of using information on internet in a meaningful way. So that the gap is gone, almost gone, right?
Right.
And if there is one difference that I envision happening within India, we are going to be in the forefront, but we'll ensure that it is cost effective and available to larger part of the globe.
Right, sir. So should we move to the next question, sir?
Please.
All right, sir. Do you think that telecommunications industry has been and will be affected even more because of the services like Gmeet, WhatsApp calls, and the rise of other such apps due to COVID-19?
I can share my observation. So interestingly, even in India or here, we always cite the wireless for the kind of communication that we're discussing, but it's actually the other way around. You use the fiber, right? So uh, in India, when I really looked at the bandwidth, it's amazing. It's much better than what I have here on this
Oh, all right.
call. On this call, and I can tell you my experience. I lose my internet connectivity at least 5 times. In my entire 3 week stay, I lost my internet connectivity only twice. Right. So I don't want you to think it's just about the telecommunication. It is the fiber which would continue to play a big role, while the wireless, right, the wireless phone. When you're on the move, right, when you're on the move. Interestingly, what did COVID do to us? It made us all sit in one place.
Right.
So we use the fiber more than
The
the
wireless.
air, right? The air. The paradigm would change. Now we are all starting to move. It was very fascinating for me to see while I was in India how the movement has already started to see the movement there. It was a little concerning, but yeah, that's how it is. So uh, the new application will continue to consume this bandwidth on the phone. We'll get better phones, we'll get better connectivity and better applications too.
Right, right. Makes sense. Obviously, you've been sitting at home, so wired connections would definitely take a better leap than the wireless ones. So we'll go to the next one. So although we can see 5G in many different fields, but are there any specific domains where the 5G tech has a lot of improvements to be made?
Oh, overall, the 5G ecosystem, it might take a few years to really stabilize. It's just the beginning. The way how it would actually work is 4G LTE would always be a fallback strategy, and then 5G would start to evolve. In terms of application, I actually see 5G private really going big, at least in the next 1 2 years. We would have 5G phones, but consistently experiencing 5G because, see, if I am in Hyderabad, where I live, I would have 5G. But as I start to move away from Hyderabad, I might not have 5G, at least now. It would take a while. It would take a few years for us to really have consistent 5G experience on the phone to support those next generation applications too. But I see 5G private. This is in industrial environment really taking off big way in a big way. These are all more commercial application driven. 5G would be like a lot of conversation. Oh, I have a 5G phone. Oh, I can see the 5G bandwidth, right? That would be this year, and we'll start to see more consistent experience, at least in the major metropolitan cities. I can say more about US, and I really have to experience in India. I'm sure it would be accelerated deployment in India as well. So the way how I summarize 2021, a lot of conversation and excitement about 5G, but the actual experience will come next year because of consistency of 5G availability across the globe.
Right, sir. So would you be willing to take more questions, or would you want to
Oh,
wrap it up with the last question now?
I'm happy to take more questions. This today's Friday, so I still have energy and enthusiasm to have more conversations with you folks.
All right, sir. So I'll ask you the next question. So, what is your view on how 5G will play in IoT markets?
Oh, that's an awesome question, actually. Um, Human experience on 5G is finite. At least in the United States with Verizon, you have 150 million plus customers sitting on the network. But what's fascinating is the entire IoT space will really take best advantage of 5G. One, to support the IoT scale, it's really required that we have the 5G fabric in place. Just imagine from 150 million consumer experience or customer experience on the phone to suddenly billions and billions of IoT devices residing or riding on 5G network, right? One, it's going to be chaotic too. Suddenly, there's so much of use, right? And this is where our team, we actually put in a lot of effort to start to surface insights about the network experience, both with consumers and also IoT as well from the fabric perspective. And interestingly, the concept that I have shared with you, the edge intelligence, we are deploying intelligence geographically in multiple locations start to surface near real-time insights. IoT and 5G is like a glue, So we across the globe, right? We are in the very, very beginning, but timing-wise, it's right. And this is where, so the way how I want all of you to think about different technologies, machine learning, distributed machine learning, IoT, robotics, drone, AR, VR. These are technologies. They are all evolving independently. What would converge is something like 5G. 5G would act as a fabric to converge all these technologies to make meaningful solutions in its respective ecosystems.
Right, sir. So now we have a slightly technical question. Sir, how latter points in neural networks is related to evolution of 5G?
It's kind of out of my domain. I might say things wrong if I actually start to dig deep. If somebody can actually break down latter points for me, and maybe I can actually start to add a bit more color and flavor. Where and how is this terminology used, please? What does latter points mean? Can one of you explain in the chat? That way, Amo can relay that back to me.
I feel there might have been something in your presentation at that point. Somebody might have pointed it out.
Got it.
So,
So,
meanwhile, we'll go to the next question while that person writes back in the chat.
no worries. A high-level view, neural network is a class of machine learning algorithms which will really change the ecosystem. Uh, uh, in 5G, are we using it? RAN, which really powers the ecosystem. A lot of machine learning capabilities are used. I don't know the specifics about the class of machine learning algorithms, but I'm sure a neural net either is used to improve efficiencies or surface insights between one of the two.
All right, sir. All right. Um, then we have, how does 5G affect backhaul networks by
Yeah.
Jyoti?
No, that's a very interesting question. So 5G is all in the air. At least in the US, there is a very strong foundation of backhaul, which is nothing but fiber, the dark fiber that actually goes around. I'm sure we might need more and more backhaul networks. I don't know the specifics in terms of are we at capacity in which geographical areas. But one thing for sure I can tell you is I'm sure there's plenty of underutilization of the backhaul network. We will start to hit that capacity, and I'm sure you'll start to see a lot of road work where you break and then add more dark fiber to connect the over the air endpoints.
Right.
But just to give context for many of the folks who are starting to understand the network ecosystem, well, there's a lot of over the air happens. There should be some network fabric that needs to connect all these antennas, and so it's the fiber optic cables, massive fiber optic cables with a lot of throughput bandwidth. All these antennas get connected in some way, form, or fashion to the backhaul network and gets routed. So the question was primarily around that. I think today we have reasonably good capacity. But what would change is the IoT that would start to ride on 5G eventually would actually put a lot of pressure on backhaul networks too.
Right, sir. And the final question for the day.
Sure.
Sir, can you tell us about 5G in autonomous vehicles?
Yeah. So one of the slides, Amog, I'll send you the slides right after this call.
Sure, sir, sure.
But one of the slides, when you take a closer look at the example that I was actually sharing, where there's an autonomous car, but this autonomous car can see only the car in front, right? Now, how can we really make it much better than what it is now? Because the car has to do a route planning, and it has to make course correction over the period of time, and so on. But how can all these things happen? So this autonomous car through 5G has to connect somewhere to get the smarts and make those intelligent decisions on the fly as it keeps moving. And very likely it might just change routes. It might take decisions to start to slow down well ahead of the actual traffic slowdown. That way it becomes meaningful, and you start to have a good journey too, because the sudden break is not a good thing at all. If you
Right.
know that the whole traffic slowing down in a few meters, which your camera can detect, then it's a pleasant driving experience. So there's no doubt 5G to really have complete full self-driving. There'll be vehicle-to-vehicle connectivity as well as over-the-air 5G connectivity to ensure safe uh, and fantastic autonomous driving experience.
Right, sir. So, with this, we end our question answer session. We would like to thank you for taking our time to have this session with us, interact with our kids, and we'd like to thank you once again. So, one final piece of advice which you would like to give our students, any one final piece of advice. They are all engineering students, so any one line would be amazing.
Oh no, definitely. So even as a student, I was very short-sighted, very focused on, say, for example, I go very deep into neural networks, but the mentality of having a view of how neural network would be applied in the broader ecosystem, if you start to have that mentality, then you'll definitely be differentiated in broader ecosystem. Because once you leave college, then you'll find your job, and then dream job, start your own company, and then so on. If you have to have the differentiated position wherever you go, you have to be different. The only way how you can be different is take all this learning and have a view how these things can be applied in a broader ecosystem. Then you have clarity of thought when you speak.
Right.
You can make a lot of difference there. And honestly, I'll tell you, I learned a lot, but it was very siloed. But don't have this siloed mentality all the way from year one, uh, especially around machine learning. See how that can be applied in solving problems with a broader view.
Right. Thank you so much, sir. With this, we'd like to end our session today. Thank you to all the viewers for joining in, and thank you once again, sir.
Thank you all very much. Bye bye. Bye, Amar.